Today's video is going to have to do with your lab that you're doing tomorrow. And I unfortunately can't be here to walk you through this, so I thought I'd record a video of all the different things I was going to say. And so the paper for the lab, you should get this today. It has one side with the instructions on it. The other side, oops, on mine it's the second page, is the data table and some questions. All right. So it's called the domino effect, and basically you're going to be setting up dominoes, knocking them down, and measuring the length of the domino train and the time it takes to fall down. So the scientific reason to do this lab is that this is something that has a velocity. So we're measuring average velocity by measuring the total length and dividing by the total time. This right here is a domino. This will be the object of your downfall when we do the lab tomorrow. And there will be some frustration, so please bear with yourselves. So what you need to do is you need to set these dominoes up with approximately the same spacing between them. They need to be set up in a straight line. And there's too many variables if we start having the domino chain be curved. And I have observed dominoes that slow down and or speed up when they go around curves. So let's take that out of the equation here and just set them up in a straight line. Now there are limits. If the dominoes are too close together, I mean certainly if they're touching, it doesn't fall down like a domino rally. It's instantaneous that the whole thing starts falling, and all you're really timing is how long does it take a single domino to fall over. Um, you can start having a little bit of space between them, and then you do get domino rally. I think you saw that that was actually pretty slow. The dominoes don't fall very quickly if they don't fall very far, and so they don't hit the next domino that hard. The other limit is if you're more than one domino length apart, then the dominoes don't. Oh, I just made a monkey out of myself. And the dominoes don't hit each other. Here, let's be absurd on this thing, okay? We put them too far apart. There we go. That doesn't work either. So somewhere between touching and one domino length apart is what we're going to do. You can start by having them be about a domino width apart, and then you can go with other settings. You're going to set 75 of these guys up in a straight line. I've only got 5 represented here, but in order to average out all the variations and fluctuations in the velocity, the instantaneous velocity, you need about 75 to get a good measurement. Once you set up all the dominoes, you're going to go ahead and measure the length of the domino train. And let's see, where'd that piece of paper go? So here's my data table here. And let's say that I set up 75 dominoes and I measured the length of that train to be 1.5 meters. Maybe I'll work in centimeters, 150 centimeters. We'll go centimeters for this. Now the number of dominoes is 75, and I really do recommend that you count this because sometimes previous students will lose a domino somehow, and then you've only got 74. That'll throw your results off. What you're going to do is you're going to divide the length by the number of dominoes to get the spacing. In this case, that's pretty easy. That's going to be 2 centimeters. Now, you're going to time the fall, and I really recommend that you have more than one person in your group rocking a timer on your smartphone. The stopwatches for the physics department have not materialized yet, so I'm going to ask you to use your smartphone as a stopwatch. So have at least 2 people ready to time on your mark and set go, and let's presume that this took I don't know, 12 seconds to fall down. In order to find the speed, you need to take the total length and divide by the time. So that would be, here, let's do that over here, 150 centimeters divided by 12 seconds. And let's just, hey, I don't have a calculator handy. So there you go. We're going to have to use the calculator that's built into my phone here. 150 divided by 12 equals 12.5. So the speed would be 12.5 centimeters per second. And you're going to do that for a number of different trials. Now, when you make the dominoes, 75 of them, when you make the dominoes different spacing, they're going to have different lengths. If you space them further apart, you might find they have a longer length, and you'll get a different spacing, and you'll get a different speed. When you're done with this table, you're going to need to do 2 things. One is to make a graph, which is asked for down here in number 6 of the analysis questions. The other thing you're going to need to do is answer these analysis questions. Now go ahead and answer them on this piece of paper, but these will need to be transferred into your lab report when you do that. So show a sample calculation for speed. All right, so that was 150 centimeters divided by 12 seconds equals 12.5 centimeters per second. How is velocity different from speed? You might write some words. Why does our calculation give us average speed? You'll write some words. What's your maximum toppling speed? Okay, when you get all of your different speeds over here, which one was the greatest? And how long in meters would a row of dominoes have to be to take a full minute? That's 60 seconds to fall down. Um, the graph. The graph is a graph of speed versus spacing. And I want the speed on the side and the spacing on the bottom. And your data will be all over the place. But what we're looking for here is there a pattern? If there were, there we go. If there were a pattern, like the numbers went up and then went back down, we might be able to conclude that there is a best spacing to do domino rally. That's the original thing I was trying to answer by choosing to do this as our average velocity lab. I wanted to see if there was one. And in the 20 years or so that I've been doing this lab, I have not found uh, a single best spacing. But people do tend to get a maximum speed somewhere in the middle of all the possible spacings. It's just that no single data has this nice little look to it. Usually the data is all over the place. If you happen to see a shape in your graph, you can go ahead and draw a line to suggest that shape. But if you don't see a shape, don't draw a line. There you go. So let's change gears here. Actually, before we go, one suggestion. You're going to have some people in your group, and they are going to be fumble fingered and they are going to knock things down. And one of the ways that you can prevent that from happening is as you set up your dominoes, take a few out to the side while you're setting up your long string of dominoes. You know, every 10 dominoes or so, take some out. So if somebody gets fumble fingered, they can only knock down so many of them and they won't take the whole string out. And then at the last minute before you go, have your best, most careful person move the dominoes into the line. That's my suggestion for sanity. Just know that it's going to happen, that someone's going to knock the dominoes over, and be kind to that person when it happens. All right, so let's change gears now. We're going to talk about how it is that you are going to write up a formal lab report, okay? So in a formal lab report, there are 5 different things that you have to have. A title page that has a purpose statement. Purpose statement is 1 sentence. List of materials, a step-by-step list of the procedure that you followed, and sample calculations and answers to the questions called the analysis section, and finally a conclusion. Now the analysis section, this analysis section calls for a graph, so I think you should attach a graph at the very end. Also in the procedure section, you're supposed to include your data. And one way to conveniently do that is to staple the table that you filled out, this guy right here, staple this table on the end of the lab. So you could write your, here, let's talk about what this would look like. So your first page is going to be just the title, Domino Effect by Joe Student. And then at the bottom, purpose. And you write your little 1-sentence purpose statement. Notice that my instructions for the lab actually follow the same kind of format, a 1-sentence purpose, a list of materials, a procedure. Wow, it is a really common science format to do this. Okay, so your first title page has got your title and the purpose statement. The second page probably should have your list of materials. There's only 3 different things here. I use a bulleted list. List of materials, meter sticks, dominoes, stopwatches, check. Then your procedure. You can write procedure and then describe what you did. If you have data to include, you could even say in the procedure section, you could say, uh, you know, data table 1 is attached. Okay, oh, that's a great looking D. There we go. Then your next section is the analysis section. The analysis section includes 2 things. One is sample calculations, Anytime you do a calculation, you should show me a sample. In this case, one of the questions asks you to show the sample calculation. So then the second thing that goes in the analysis section is the answers to the questions. And then finally, your last page will include a conclusion. And that's just a couple of sentences of how you did your lab. For this lab, I think you're definitely going to have this page and this page. Um, and this conclusion might actually make it onto that page. So you're probably going to have 3 pieces of paper that you have to type up, one of which doesn't have much writing on it. Then you're going to have a graph, which will be in the landscape format, so it'll look like this. And then you'll have the data table that you made. You could even cut this out and paste it in someplace. That might make it work out. And all of this, all these 5 pieces of paper are going to get stapled together and turned in 1 week after we finish the lab. That's the rule on formal labs. They're due a week after we do the lab. So I'll put the due date in the Google Classroom, but if you're at all confused about it, it's due a week later. Um, it says here in the instructions for how to write up a lab, where did that go? Here it is. Some important information here. The data will be the same for your entire lab group, but all the writing must be your own. Anytime you have a procedure section or a conclusion or a purpose, it should be written by you. I guess the purpose may be vastly similar to your partners, but definitely the procedure section should be different. It's not a group project, okay? I need to be able to tell the difference between people who are writing these up. Okay, I hope that gives you enough information. Again, be calm tomorrow. Uh, if you have a clumsy member of your group, make them the recorder and don't let them set up the dominoes. All right, and I'll see you guys on the other side.